Our demo today covers Photoshop layer separation. We're utilizing this technique now because it allows us to simulate the outcome of a screen print at a time when we can't make the print physically. But this skill is also helpful for planning a print in a more traditional studio context, allowing you to experiment with color, spot potential errors, and more before ever making a transparency or shooting a screen. In essence, layer separation is the visual skill of reverse engineering a complex image into distinct layers. In any printmaking medium, understanding how layers align and interact with one another is crucial to printing complex compositions. Once you've been printing for some time, a lot of this thinking becomes second nature, but it takes practice to correctly anticipate color mixing, shape transparency, tone depth, and other interactions. I'm going to show you how I would turn an existing piece of art into a screen print. For the sake of your own planning, imagine this image as the colored drawing or sketch that you're using to plan your print. Whether it's something with as much detail as my image has, or something looser and simpler, what's most important is that you have a visual depiction of what you hope to achieve before you begin to create your layers. First, I'll study my image to see how it can be visually divided into distinct color segments. If we assume here that we're printing on white paper, we see that the dark blue background can be relegated to its own color layer. As I continue to examine the image, I can keep in mind that at least one area is already dark blue, allowing me to incorporate other areas of the image into that layer if needed. Here, for example, that dark blue also becomes part of the shadow below these shoes, so there's no need to make that its own layer. Then I look at the overall tone of the rest of the image. There are some white elements, like these shoes, which means those are areas where every layer should be empty, so that the white of the paper can show through. It also looks like the character of the image becomes more of a sky or light blue below, so I think I'll take the floorboards and turn them into a light blue color. That leaves us with two distinct flat color layers. But then what about all of this detail and tone? In this case, I'm going to keep all of that tone on another dark blue layer called a bitmap, which I'll explain more soon. But for now, to recap, when printed on white paper, our image has three distinct layers: a dark blue layer, a light blue layer, and a tonal bitmap layer. Let's start building it. First, make a new file, taking into consideration how big you want your final print to be. I'll make this one 18 by 24 inches, and I'm using 300 dpi here. In general, a finer or higher number dpi is more desirable because it allows for subtler tonal shifts, but the mesh in a silk screen acts similarly to a screen pixel and how it translates images, which is a little limiting. So from experience, I know that 300 dpi is fine enough to offer a nice range without losing its character when you expose your screen. Now we start to make the layers. I'm importing my reference image as a background layer and bringing it up to scale. Beginning with the blue background layer, I look at all of the areas where the dark blue completely permeates the image, and make a layer that encompasses only those areas. In this case, that means no shoes and no baseboards, just the background and the shadow. There are a variety of ways to select that layer in Photoshop, but I prefer the polygonal lasso tool rather than the magic wand, because it allows for more artistic control and decisions about where the layer boundaries fall. Unlike the free lasso tool, you can take your time with the polygonal lasso. Once I'm satisfied with my selection, I create a new fill layer and choose the hue I'd eventually like to print this layer with. Next, I build the light blue layer. Because I have already created that negative space with the dark blue layer, I can use that as a shortcut for creating the color that fills that space. As you can see, I can use this to make another fill layer. But if I use my imagination a little bit, I can also use this to make a gradient layer, as if I were printing this layer using the split fountain technique. This allows me to get a bit more tonal complexity, without having to burn an additional screen or account for more margin of printing error in another layer. The other thing to notice here is that we now have two fill layers whose edges are perfectly registered together. If you were printing this, that would pose a significant challenge for you. Any slight movement in the screen or paper would show itself immediately. So we create something called trapping, in which you expand the lighter color layer to allow for a slight overlap between layers, giving you some wiggle room. I do that here by clicking the fill selection and then choosing expand selection, experimenting with the number of pixels that looks visually right when I view the image at 100%, its real-life scale. Now I have a layer with some trapping in it. But Photoshop doesn't reliably depict for us what two ink layers look like when they overlap. It thinks every fill layer is completely opaque and impermeable. We know that a light blue layer on top of a dark blue layer looks different than a light blue layer on white. So we simulate this by setting the layer opacity style to multiply. Now we can see that the light blue layer should sit behind the dark blue layer in order to most effectively hide the trapping. All that is left is the bitmap layer. As you know, screen printing exposures only allow for images that are entirely black or entirely white. No tones, just negatives and positives. So we need to convert the tonal layer into a series of opaque dots that vary in size and distance, creating the illusion of tone. To do this, I take the relevant parts of this image and pull them into a new window. First, I make my image grayscale. Next, I convert to bitmap, prompting a series of questions. Again, based on previous experience, I'm going to choose halftone at 300 dpi and a size of 35, and advise you to do the same. Place the bitmapped image in the new window. Select the single color areas of the image, and create a new fill layer with the ink color you'd like to use for this layer. And once again, set that layer to multiply to get a better understanding of how these ink layers might overlap. These simulations aren't entirely accurate. Once you get into the studio, you'll need to test your ink through drawdowns as you would with any other print, but they're close enough to help you get started. You'll also want to consider how this image sits on your paper. Is it full bleed? If not, you should either scale down your composition within the window, keeping the paper size constant, or expand the canvas of your file, expanding the paper size around an unchanging image size. For now, in this digital learning environment, you've simulated the outcome of a multi-layer screen print with photo emulsion. As you think about sharing and promoting the work you make while studio learning takes place remotely, consider how posting a series of these images in a carousel or as an animated sequence can help tell a story about how you've developed an eye for printmaking.